Hello and welcome to another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and today we'll be doing Unit number 9, Lesson number 7, Final Work with Quadratic Equations. Before we begin, let me just remind you that you can find the worksheet and a homework assignment that go with this video by clicking on the video's description, or by visiting our website at www.emathinstruction.com. As well, don't forget about the QR codes on the top of every worksheet. Scan them with your smartphone or your tablet and it will bring you right to the video associated with that lesson. Alright, let's begin. In the last few lessons and in the last unit, we saw a lot of different ways to solve quadratics. The three main ways are to solve by factoring, to solve by completing the square and using inverse operations, and to solve by using the quadratic formula. Alright, what we're going to do in this lesson is essentially just review each one of those one final time. It doesn't hurt to get practice, and you never know which method you'll be asked to use. Probably all of them in a given test. Anyhow, let's jump right into it. So exercise 1 says solve the following in quadratic equations using the required method. First, arrange the equations so they're set equal to 0. And that's important because each one of the procedures, whether it's factoring, solving by completing the square, or solving using the quadratic formula, each one of them at its essence requires us to get the equation equal to 0 first. So let's take a look at letter A. We have x squared plus 5x minus 12 equals 8x minus 2, and we are to solve by factoring. Okay? So that means the zero product law, the ZPL. Yeah, like I've ever used that before. Okay, so what I'm going to do is I'm going to get this side equal to 0. I'll do that by subtracting an 8x from both sides and by adding a 2, right? I just have to do the opposite of what's been done here. That will give me x squared, nothing will combine with that. 5x minus 8x is negative 3x, and negative 12 plus 2 is negative 10. All right, now that my quadratic is equal to 0, I can use the zero product law, which means that I'm going to factor each side. Shouldn't be too tough because that leading coefficient is 1. I need to now figure out these two, which will be minus 5 and positive 2. I should check. That'll be negative 5x. Positive 2x gives me negative 3x, so that checks. That means I'll have x minus 5 equals 0, or x plus 2 is equal to 0. I'll add 5 to both sides, and I'll get x is equal to 5. I'll subtract 2 from both sides, and I'll get x equals negative 2. All right, putting my answers in roster form, solution set form, negative 2 and 5. All right, it's actually been a little while since we've really solved by factoring. I mean, we've done it here and there, but primarily that was in the last unit when all the answers were rational numbers. Okay, but let's take a look at letter B. Solve by completing the square. All right. So again, I would like to get everything equal to 0, so I'm going to add 3x to undo the subtraction, or the negative 3x. I'll subtract 4 to undo that. And again, I can do this all at once. I just want to be careful. Make sure I combine the correct terms, right? Negative 15x, positive 3x is negative 12x. 24, negative 4 is positive 20. Now, in order to solve by completing the square, what I really need to do is I need to get it in vertex form, so to speak. So what I'm going to do is I'm going to take that b, that negative 12, remember that leading coefficient's 1, so I'm kind of good there, divide it by 2 and square it. So that's going to be negative 6 squared, which is going to be positive 36. So I'm going to add a 36, but remember, as always, you must also subtract a 36 so that you're adding a whole lot of 0, a whole lot of nothing. Now that is a perfect square trinomial, and it happens to be x minus 6 squared. All of this becomes negative 16 equals 0. And again, the advantage of this is that now the x is showing up only once as opposed to twice, right? So we can undo what's been done to x. In other words, x has had 6 subtracted from it, then squared, then 16 subtracted. So since 16 being subtracted was the last thing that happened, it will be the first thing I'll undo. So then I'll get x minus 6 squared is equal to 16. I now need to undo the squaring, so I'll take the square root of both sides. Remember that always introduces a plus minus, in this case plus or minus 4. Then I'll get x minus 6 is equal to negative 4, or x minus 6 is equal to positive 4. Add 6 to both sides, I'm running out of room, and I'll get x equals positive 2. Add 6 to both sides here, and I'll get x equals positive 10. So my solution set will be positive 2, positive 10. All right? Very, very different ways. Very different ways. Now what's interesting is that because those answers turned out to be rational numbers, right? Both 2 and 10 are rational numbers, then that actually implies, if you remember this from a previous lesson, that we could have done it using the zero product law. But the problem said solve by completing the square, so that's the way we had to do it. All right? So pause the video now, and then we will go on to letter C and letter D. Okay, let's do it. Letter C. Solve using the quadratic formula. Express answers to the nearest tenth. All right. Again, the quadratic formula requires us to have our quadratic equal to 0. So I'm going to subtract a 5x from both sides and a 15. That's going to give me x squared. Negative 3x, negative 5x, watch out, is negative 8x. 16 minus 15, that's not too tough. It's positive 1. And now I have to use my quadratic formula. A is 1, B is negative 8, and C is 1. My quadratic formula, if you remember, is negative b plus or minus the square root of b squared minus 4ac divided by twice a. So it's kind of plug and chug. Now I'm going to try to speed this up. A negative negative 8 is a positive 8, right? So that's negative b plus or minus, here I'm going to slow down a little bit, b squared minus 4 times a times c all over 2 times a. Okay? Take your time, make sure that you do this correctly, this part. All right? So I've got 8 plus or minus the square root. Negative 8 squared is 64. 4 times 1 is 4, times 1 is 4. Sorry about that. I'm going to put a line right here so it's not overly confusing. 2 times 1 is 2, so I get 8 plus or minus the square root of 60 divided by 2. Now notice there's no mention in this problem of simplest radical form. So that means that we really shouldn't think about simplifying the square root of 60 at all. In fact, we should take our calculator out and we should type this in. Now I always do this in stages. I do 8 plus the square root of 60, I get an answer, and then I divide by 2. This wanted my answers to the nearest tenth, so 8 plus 60 divided by the square root of 2 is 7.9, accurate to the nearest tenth. All right, and then I'll get 8 minus the square root of 60 divided by 2, and that to the nearest tenth is 0.1. All right. Ooh. Letter D, solve using the quadratic formula, but express your answers in simplest radical form. All right. So what do we do? Well, we have to get rid of this negative 2x, so I'll have to add a 2x to both sides. Get rid of this addition by 7 by subtracting 7 from both sides. That will give me x squared plus 6x. Watch this. 2 and negative 7 is negative 5. All right. So a is 1, b is 6, c is negative 5. I've got the formula written right there. I'm not going to rewrite it. So I've got negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. That'll be negative 6 plus or minus. Of course, 6 squared is 36. And again, as I pointed out before, get me back into that presentation. As I pointed out before, I don't know why that happens. Watch for double negatives, right? I tend to tell students, just turn them into positives immediately, or be very, very careful when you enter this in your calculator. So maybe take the entire expression right here, enter it in your calculator. Just make sure, because you don't want to mess something up that's just pure arithmetic. And you'll find that it's 56. All right. Now the problem is we have to write this in simplest form. Okay, let me put a little line here so we really kind of demarcate these two problems. Okay, so let's start to simplify that numerator. All right, we look for the biggest perfect square that goes into 56. That happens to be my favorite. One of these days I got to use something other than 4. But anyway, 56 is 4 times 14. Okay, so now we take the square root of 4 and we get 2, and we leave the 14. And now we use the distributive property. We do negative 6 divided by 2 plus or minus 2 divided by 2 times the square root of 14, which gives me negative 3 plus or minus 2 divided by 2 is 1. So negative 3 plus or minus the square root of 14. Wow. Wow. That takes a little bit to get through, doesn't it? All right. But it's a good procedure. Whether you're using factoring, the quadratic formula, completing the square, every time get your equation equal to 0 and then follow through on what the problem is instructing you to do in terms of which method to use. Okay? So pause the video now, take some time to write down any of this quadratic formula work. All right, we're going to clear it out. Okay, so let's take a look at one final thing that goes along with the quadratic formula and all the work that we've done on zeros. Okay, and it's kind of cool. So exercise 2 says the quadratic f of x equals x minus h squared plus k is shown graphed on the grid below. First question, what are the values of h and k? All right, pause the video now and think about that. What's the value of h? What's the value of k? All right, well, we've gone in the opposite direction many times, haven't we? So when you've had a parabola in vertex form, if I had something like f of x equals x minus 7 squared plus, let's say, 1, we would know that the turning point was at 7, 1. On the other hand, what we know here is that the turning point is at 2, 4, so those are the values of h and k. H is 2, k is 4. All right? Now, letter B says, what happens when you try to solve for the zeros of f given the values of h and k from part A? Why can't you find solutions? Well, let's try to find solutions. I take that as kind of a dare, right? So what I'm going to do is I'm going to put those two values in. X minus 2 squared plus 4 equals 0. Now the beautiful thing is we can sort of choose our method, but I think you'd have to be kind of crazy if you chose anything but trying to solve this by using inverse operations, right? There's only one x. X has been subtracted, or x has had 2 subtracted from it. Then we've squared, and then we've added 4. So let me subtract 4 from both sides. I'll get x minus 2 squared. 0 minus 4 is negative 4. Then I'll take the square root of both sides, and I'll get x minus 2 is equal to... we cannot find the square root of a negative number. So what happens? Well, we get stopped. That's what happens. We get stymied. But what's cool is that there's a practical there's a practical repercussion of that. I was about to say reproduction, and that's strange. There's a practical result of the fact that we can't find the zeros. And it shows up in the fact that the graph has no zeros. The graph has no zeros, right? Zeros are the same as the x-intercepts, right? I mean, it doesn't. It's a parabola that's above the x-axis and is opening upwards, and it never hits this x-axis, never hits it, right? Nobody said that every parabola has to have zeros. In fact, you can easily have parabolas. Let's draw one that opens downward, right? That never hit the x-axis. And the algebra can't lie, right? The algebra doesn't lie. In other words, if I use the algebra to find the zeros and I get stymied along the way, I get stuck because of something like the square root of a negative number, well, then that tells me that the graph won't have any zeros. Isn't that kind of cool? In Algebra 2, you'll work a lot more with this. In fact, the number under the square root, in the quadratic formula at least, is called the discriminant. And you'll look at what a negative discriminant really means about the graphs. We're going to play around with it with one last exercise and then move on. All right, so I'm going to clear this out. Whoops, I'm sorry, I didn't give you a chance to copy it down. My apologies. So what I'll do is I'll make sure that in the next slide, in the next frame, we really try to understand this well. You can, of course, also rewind the video, but that's not as convenient. Anyway, let's move on. All right, so exercise 3. Which of the following 3 quadratic functions has no real zeros? There may be more than one. Determine by using the quadratic formula. Verify each answer by graphing in the standard viewing window. All right, well, let's do it. Let's just find the zeros. So what I'm going to do is I'm going to take my quadratic and I'm going to set it equal to 0. And I'm going to use the quadratic formula. Here, a is equal to 1, b is equal to 7, c is equal to 1. Let me write down the quadratic formula so that we have it sitting in front of us. I know that this is a tough formula to memorize at first, so that's why I like to have it down on my sheet as many times as possible. Here I'll have negative b, which is negative 7, plus or minus the square root of 7 squared minus 4 times a times c, all over 2a. Now what's interesting is they never actually told us to figure out the zeros. They told us to figure out whether they have zeros or not. Well, let's keep going. All right, 7 squared is 49. 4 times 1 is 4. So I'm going to get negative 7 plus or minus the square root of 45 divided by 2. Now, here's the key, right? Since that is a positive number, right, it doesn't matter that it's not a perfect square, the answer is yes. It will have real zeros. Okay? Now, I don't think I'm going to open the calculator quite yet. What I'm planning to do is do each one of these 3, and then we'll take a look at each one of the graphs, okay? So let's go ahead and do the second one. See what happens there. Sorry about that. We'll set 3x squared plus 2x plus 4 equal to 0. Quadratic formula, a is 3, b is 2, c is 4, x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a, negative 2 plus or minus square root, 2 squared is 4, 4 times 3 is 12, times 4 is 48, all over 6, and that will give me 4 minus 48 is negative 44 divided by 6. But that's a problem. We can't have a negative under the square root, right? We can't find the square root of negative 44, which means this will not have any. Okay? And let's do one more. Okay, let's set 5x squared plus 2x minus 3 equal to 0. A is 5, b is 2, c is negative 3. So x will be negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So negative 2 plus or minus square root 4. Look at that double negative, right? So I'll turn that into a positive. 4 times 5 is 20, times 3 is 60, divided by 10. That gives me negative 2 plus or minus the 64, divided by 10. And again, take a look at that. It's positive. So yes, there will be ones. Now, what's cool about this is we can see definitive proof. So the first one should have x-intercepts, the second one shouldn't, and the third one should. So let's open up our TI-84 Plus yet again. There it is. All right, let's go into y equals. Okay, clear out any equations you might have there. Take a moment to do that, and I'll clear out any I might have. All right, and I think we should put in all three of them at once, keeping in mind that the first one graphed is the first one, the second one graphed is the second one, etc. So in y1, I'm going to put in x squared plus 7 times x plus 1. Check it over a little bit. Okay, go down to y2. I'm going to put in 3x squared plus 2x plus 4. And in the third one, go down to y3. I'm going to put in 5 times x squared plus 2x minus 3. All right. I want to give you a chance to catch up. I also want to look at all of mine just to make sure they're right. All right. Looking good. Okay. Okay, I think they're all good. All good. Now we have to set the window. Notice how it says the standard viewing window. That means negative 10 to 10, negative 10 to 10. Why don't we just go and do that manually? Let's go into our window setting right up here. X min I'm going to put in as negative 10. X max I'm going to put in as positive 10. Y min I'm going to put in as negative 10. And Y max I'm going to put in as positive 10. All right. So now what we can do is we can eventually hit graph. Now again, before we even do that, I want to emphasize that as they graph, the first one that comes up will be one where we think it'll have x-intercepts. The second one is one where we don't think it'll have x-intercepts. And the third one is one where we think it will again. Okay? All based on the quadratic formula and whether a negative showed up under the square root. So let's do it. Hit graph. This is going to take a moment because it's got to graph all three parabolas. So let's kick back and relax. I wish I knew the Quadratic Formula song right now. I'd start to sing it. They do exist. Google it. Google Quadratic Formula song. All right. And what we see is exactly what we thought we would see. That first parabola there, right? That one has x-intercepts. Okay. The second parabola, though, opens upwards and always stays above the x-axis, so it has no x-intercepts. The third one, by contrast, has x-intercepts again. All right? So it's kind of cool, right? The quadratic formula, or really any of the methods that we've used to find the roots, can tell us whether or not the thing has zeros. Probably the least helpful is factoring, because quite frankly, factoring will only work if your roots are rational numbers. So it's not so easy to tell when they don't exist at all. Okay, I'm going to get rid of the TI-84 Plus. All right, and now pause the video if you need to and write down anything you have to. All right, let's clear out the text. And let's wrap. All right, so today's lesson was really just a summary lesson, right? It was how do we use the quadratic formula? How do we use the method of completing the square? How do we use factoring to find the zeros of a quadratic or to solve a quadratic equation? All right. The key in all methods is to get the equation first equal to 0 and then follow whatever procedures exist. The other major thing that we saw, though, was that some parabolas don't have x-intercepts. They don't have zeros. And both the method of completing the square and the method of using the quadratic formula can show us that. The way it shows us it is if a negative ends up showing up underneath the square root. If that's true, no zeros, no x-intercepts, at least no real ones. All right. For now, I'd like to thank you for joining me for another Common Core Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.